Hi, I'm Kim, who will introduce about the quantum bit, qubit, and the natural qubit, electron. Classical computer uses bit, and bit has two states, 0 and 1. Quantum computer uses quantum bit, which is qubit, and the qubit can express both 0 and 1 at the same time. This makes quantum computer more powerful. For n qubits can contain 2 over n informations, it looks much efficient than classical bit. There are several natural materials that can make qubit: single photon, nucleus, electron, etc. I will focus on the electron. We can make qubit with outmost electron of phosphorus. Put this atom in a tiny register. All electron has magnetic field. It makes a tiny magnetic dipole in an atom, and it is spin. Actually, spin is a quantum mechanical term, but we can think electron spin as spinning charged particle. We can control the spin state of electron with strong magnetic field. If we place electron in magnetic field, we can align the direction of spin. This is the aligned state with lowest energy level, and this is called spin down. It means 0 in classical bit. If we give some energy, we can change the direction of spin, and it's called spin up, and it has highest energy level, and it means 1 in classical bit. You have to give exact energy to change one electron spin state to another. It does not take huge energy to change spin state, so in room temperature, by thermal energy, electron vibrating between spin up and spin down occurs. They can be in both states at once. Electron is in quantum superposition before an observation with certain probability. As you can see in the right picture, there are many up and down spins, and after a few times, the spin states will be changed. Up can be down, and down can be up. And this change will occur again and again and again. From this property, we can use electron as qubit. And as I mentioned, this spin status could work as classical bit. Up spin is 1, down spin is 0. Then, how the electron spin works in a circuit. The phosphorus atom will be inserted inside the transistor, in this case, MOSFET. Spin down has raw energy, and the raw energy electron cannot overcome the potential barrier on the transistor. However, up state can pass the transistor. So, spin up electron make the transistor possible to pass the current. So, spin up works as 1, and spin down works as 0 in this transistor. Next, I will briefly talk about 2-qubit case. We have 4 quantum states: up state, T0 state, single state, down state. Why we describe with T0 and singular state is there is no natural state for 2 qubits that it presents down up or up down. Because they are coupled, fix the one electron in a different state with the other is impossible. The state will be swapped again and again as time goes. If we prepare it up down, it will not stay, eventually turned into down up, and again turned into up down, and again and again and again. We cannot say one is down and one is up. We can just say 2 are in different directions. Then, what is a stable configuration for this coupled state? First thing is superposition of up down and down up with same phase. Second is the superposition of up down and down up with opposite phase. In this superposition, the state will be stable. That's why we use T0 and singular state. As you can see, T0 uses plus sign and singular uses minus sign. Each means same and opposite phase. Let's wrap up this video. As you saw, 2 qubits makes 4 states. At the very first of the video, I told that n qubits can represent 2 over n states. And electron could be used as a qubit with the superposition of spin up and spin down. The last thing is the topic that I didn't mention before. We learned about the observation result of quantum states in MS 310 class. For one observation, we can only get one specific value at that observation. It means for individual operation or calculation, Qubit also works as same as classical bit. Qubits are not universally fast, only fast for some special types of calculation where we can use the property of superposition. For example, faster in parallel computation. That's why a quantum computer is not a future replacement device for a classical computer. The advantage is not on the speed of individual operation, it's on the number of operations that can calculate at the same time with superposition. This is the end of the video. Thanks for watching me.